So we've previously talked about double integrals over general regions. We've discussed regions that could be described by functions x of y, right? So functions of y. We also discussed regions where you could describe them by functions of x. So here's regions described by functions of x. Here's regions described by functions of y. And finally, what do we do about more general regions? Well, what we could do is decompose our region into regions that may be described by either a function of x or a function of y. So we'll take this R and break it up into R1 and R2, where R1 may be of the type that could be described by a function of x, and R2 could be described by a function of y. And they don't overlap, or they can overlap, but at a line or a point. Okay, so if these two regions, they can't overlap over an area. Okay, but if they overlap over some a line has area zero, right? Almost, you could think about it that way. So either they don't intersect, or almost they don't intersect. They only intersect at lines and points. And you then break up that region into R1, R2, and you carry out this integral that you see here. And that's pretty analogous to what we did here. When we insisted on integrating over dy, we basically decomposed our region into the one in pink and the one in blue there. And we carried out the integral as a region with bounded or described by functions of x, but we have to decompose them to do that. Okay, you can't consistently describe the top bound as one function here, or it's not the most convenient way to describe it, at least. So we broke it up into regions. Of course, you could also play around with the idea of the absolute value, but the simplest way to do that is really to just do it as a function described by functions of y. Nevertheless, decomposing also works, and that's how you will deal with more general regions.